All right, this is question 5 of the Kilbaha 2025 exam. Now it says show that the composite function fog does not exist. So in doing this question, I'm going to first draw up a table. And in drawing up this table, I'm going to draw, we've got the domain, we've got the range, and we've got F, and we've got G. So what I'm going to do is I'm going to investigate what is the domain and range for each of these functions. So for F, I've got a square root underneath on the bottom. So I need to work out what my maximal domain is. Now in this case, any negative number for the x, so in other words, let's just solve this. We're trying to solve x minus 4 is equal to 0, x is equal to 4. So the question is, we've got 4, but is it going to be in the infinity or is it going to be in the negative infinity? In this case, we would say it's the positive infinity, because if we go to negative infinity, this becomes a negative square root and it becomes undefined. So we're going to say it is from 4 to infinity. Okay, and as a result, from going 4 to infinity, we need to think about what our range is, and since it's got that asymptote there, we're going to go from 4 to infinity, so it's from here, and it's going to be at 0. So 0 to infinity, not inclusive. Next one is, we've got a negative parabola. Now the negative parabola is of the form x5 minus x squared, x. So we've got here 0, 5, some sort of parabola that goes like that. All right, now what is the domain and range? The domain for this parabola, there's no restriction, so it's all real numbers. So I might say negative infinity to infinity. And the range of this graph will be up to whatever the turning point is, but up to negative infinity. So if we do a quick completing the square of this equation, so we've got negative x squared plus 5x. If we do a completing the square, that becomes negative x squared. We've got minus 5x. Okay, so that completes to x squared minus 5x plus 25 on 4, because we've got to take the 5, half it, and then square it. So I'm going to write this maybe as 5 on 2 squared. Okay, and we're going to balance it out on the other side. So we end up getting equals 25 on 4 on the other side. And then when we rearrange this, we get the equation as negative x minus 5 on 2 squared minus 25 on 4. So the turning point is going to be at 25 on 4. So 5 on 2, 25 on 4. That's positive, sorry. Yeah. Subtract. Positive, yeah. Yep. Okay. So from this point, we need to then say this is up to 25 on 4. And it's inclusive because it's a turning point that is defined at that point. So we need to have a look at when does fog does not exist. The condition for this is fog does not exist if the range of G, range of G is a subset of the domain of F. Now in this case, we'd have a look, and the range of G is negative infinity to 25 on 4. Okay, is that a subset of domain of f? The domain of f is 4 to infinity. So 25 on 4 is not a subset. Therefore, fog does not exist. Okay. So now the next question follows on with, if it doesn't exist, how can we make it exist? So we need to have a look at what's stopping us from making this. Like, what's wrong with this? At the moment, we see 25 on 4. Does that fit within the domain? Yes. The problem is this negative infinity. It doesn't fit within this particular domain. So in order for it to be defined, we need to knock this negative infinity such that, I guess you could say, the range is at 4. So the range of g needs to end at 4. So what we need to do now is we need to have a look at g. In this case, g is 5x minus x squared. And we're going to see, where does that actually equal 4? So if we rearrange this, we get negative x squared plus 5x minus 4 equals 0. Take a negative out, x squared minus 5x plus 4 equals 0. And then from here we can factorize. Let's take that negative over to the other side since we're solving. This becomes x minus 1, x minus 4 equals 0. So therefore our solutions are x is equal to 1, x is equal to 4. But what does that actually mean? Is it going to be above or is it going to be below? And if we investigate this graph here, if we go x is equal to 1, x equals 4, okay, we want that domain. That domain is where it's going to be defined. So the question is, what's the domain for where this can be defined? Well, it can be defined for x is in between 1 and 4, and it can include, no, it can't include in this case, because if we've got 1, okay, so now the domain of f is 4, so that means we can't include 4, so that means this one here is non-inclusive, because the domain of f is not included in this case, so it's round brackets or non-inclusive. So as a result of that, now that we've got the domain, it says fully define h of x with the rule and the domain. So now we're going to find what actual fog is. So fog is equal to, when we sub it in, we've got 1 over the square root of 5x minus x squared minus 4. And then so if we write this in fully fledged definitions, or we can write this for the bounds of x is between 1 and 4. So the key thing here is to recognize that when you've got fog and goff, if it's not defined from this step here, how do we knock it so that it is defined? Okay, and what we knocked was the range. So as a result of that, to get this range, what did we need to restrict the domain to? All right, question 7 says sketch this graph below. For here, I can see there's an asymptote at 1 and negative 2. So I'm going to draw my asymptotes going downwards like this. Let's say x is equal to negative 2. One's going across. So this is y is equal to 1. And then I'm going to find my intercepts by saying x int y equals 0. So we get 0 is equal to 4 over x plus 2 plus 1 minus 1 brackets x plus 2 equal to 4. Negative x is equal to, so negative x at 6, x is equal to negative 6. And my y int is at x equals 0. We get 4 over 2 plus 1, which is equal to 3. So my y is equal to 3. So I've got 1 there and 1 there. And my graph will follow that sort of direction. And let's follow there as well. All right. Write down the rule for the inverse function of f. Now, for this one here, we need to be very careful because it doesn't look like there is any sort of overlap. So what we can do is we can just switch the x and y coordinates. In this case, if we switch the x's and y's, we get x is equal to 4 over y plus 2 plus 1. Rearranging this, we get x minus 1 is equal to 4 over y plus 2. Switch the 2, so we get y plus 2 is equal to 4 over x minus 1. Therefore, y is equal to 4 over x minus 1 minus 2. And we need to make sure that we state that the domain can be where x is an element of all real numbers except for 1. All right, next question. Find the coordinates where it intersects with its inverse. Now, this one here, a lot of students would just equate the two. Keep in mind, you can just equate this to when one of the graphs equals x. So it could be one or the other, doesn't really matter which one. I'm going to choose probably the original equation. So I'm going to find out when does 4x plus 2 plus 1 equal x. So if we rearrange this, this becomes 4 is equal to 4 over x plus 2 is equal to x minus 1. Okay, expand the 2, 4 is equal to x minus 1, x plus 2. 0 is equal to x squared plus x minus 6. Okay, after you rearrange, then refactorize x plus 3, x minus 2 equals 0. Therefore, you've got x is equal to 2, x is equal to negative 3. Now we need to find the points of intersection, so we're going to sub it back in. So from here, if we plug 2 back into here, we get 4 over 4 plus 1. So that means 2, 2 is your coordinate. And if we substitute negative 3 into there, we get negative 3, negative 3. So we can substitute back in. On the same set of axes, sketch the graph where the inverse is where x is greater than 1. So something here we need to consider is that if the original had an asymptote at y equals 1, the inverse will have an asymptote at x equals negative 1. Okay, and this one here will be at negative 2. So x is equal to negative 2. And if we know that we're only dealing with the positive quadrant, since we've got a y-intercept here of 3, 0, this one here will be, 0, 3. This one here will be 3, 0. Okay, 3, 0. And we should probably have a point of dilation as well. So at, for example, 4, what will you get? So 4/3. Actually, let's choose another point. Let's choose 5. At 5, because you get 4 over 4 minus 2, so we get negative 1. So at 5, we get negative 1. That's our point of dilation. And that's our graph for something that's greater. All right, looking at the next graph, it says in the quadrant, first quadrant, S is enclosed by this graph and both the x and y axis. Find the area of S. Ooh. So what area are we actually asked to find in this question? So if we go to our graph and we draw a line here, I'm going to make this a little bit thicker. So it's line y equals x. We're asked to find, sorry, this pink line should really stick there. Okay, so we're asked to find the area that's bound. From what I understand, this part should probably use maybe, we'll use yellow. This part here. Okay, that's the area that we're asked to find. But in order to find the area, what we can do is we can just find this first area over here. And then when we find that first area over there, we can double it because it's using the inverse property. And we just need to recognize at that point there is 2, 2. And therefore we can go purple line, subtract blue line from 0 to 2. All right, so let's do that now. So for this one, we've got, so from 0 to 2, which is the purple line was f of x, subtract x dx, and we need to make sure that's doubled because we've got both the top component and bottom component. So this turns into the integral from 0 to 2 of f of x was 4 over x plus 2 plus 1, and then we're going to subtract x dx. All right, let's be careful with this one. So the integral of this, or the antiderivative of this, is going to be 4 log and the bottom, and then plus x. So let's be careful. So this now becomes 2 square brackets 4 log e x plus 2 plus x minus x squared on 2. And we're evaluating this from 0 to 2. And then when we substitute our values in, this becomes 2 brackets 4 log e 4 plus 2 minus 2 squared on 2 is 4 on 2, so that means that's 2. These two cancel out, and we're going to subtract that with 4 log 2 plus 0 plus 0. So that means that's that. Okay, now I might just write this out to neaten it up. So it becomes 2 times 4 log e4 minus 4 log e2. Okay. I'm going to now expand the brackets, so that becomes 8 log e4 minus 8 log e2. And then from here, I'm going to convert this to 8 log e2 squared. And chuck that at the front, that becomes 16 minus 8 log e2. And then, okay, we're going to make sure we're not using our log laws prematurely. So what we're going to do here is we actually got to convert that to log e2 to the power of 16, subtract log e2 to the power of 8. And then from here, we can use the log laws where we divide through. So 2 to the power of 16 divided by 2 to the power of 8 means you subtract the powers. We've got log e2 to the power of 8 as your answer here, which just checking how do they want it in the long form. So that means 2 to the power of 8 is log e 256. And find the area of S. Is that? Yep, that's all right. That's your area. So area equals that. All right. Next question says you've got a family of rectangular hyperbolas, and you're trying to find where do these have points of intersection that are more than 1, 2. I'm thinking in this case, just by looking at the prompts, to look at the discriminant. So what I'm going to do here is I am going to work out where does this equal x, because it's talking about the graph and the inverse. So I'm going to equate b over x plus 2 plus 1. Where does it equal x? And then I'm going to investigate that as a discriminant question. And then the discriminant question will tell us whether or not it's got 0, 1, or 2 points of intersection. So from here, we get b over x plus 2 is equal to x minus 1. B is equal to x minus 1, x plus 2. And then from here, we want to make it into a quadratic and expand. So b is equal to x squared plus x minus 2. And then we can say that our quadratic now becomes x squared plus x minus 2 plus b. That equals 0. So now this is our a value, that's our b value, and that's our c value. So we're going to look at discriminant, and we want 1 point of intersection, so we find out where does it equal. So b squared minus 4ac is 1 minus 4 brackets 1 brackets, in this case, minus 2, well, minus 2 brackets plus b equals 0. So it's okay. So if you just tread carefully, let's do the expansion. We got 4 brackets negative 2, negative 2b is equal to 0. 1 minus negative 8. Okay. 1 minus, okay. 1 minus positive 8 plus 2b, not 2b, sorry. That becomes, yeah, where did I get the 2b from? Sorry. That becomes minus 2b, that becomes plus 4b, and then that equals 0, so that becomes 9 plus 4b is equal to 0. Therefore, b is equal to negative 9 on 4. Okay, so for the b values of this, there will only be 1 point of intersection. So the question is, where will there be 2 points of intersection? And 2 points of intersection exist when discriminant is positive. So what I'm going to do is I'm going to sketch this graph, and I'm going to think about it in terms of where are my intercepts in this case. So we don't really have a good indication of what the intercepts are. So we're really just trying to work out where does 1 minus 4 brackets minus 2 plus b, where is that greater than 0? Okay, so that's greater than 0 when b is greater than negative 9 over 4. Okay, so when is b greater than 9 over 4? We need to take into consideration there's a couple of things. B cannot be 0, so b cannot be 0 because it's defined here. And the other thing that we need to consider is no, that's pretty much it. So we've got the solution here that b can be negative 9 on 4 to infinity, but we need to make sure that we exclude b is equal to 0. Excluding b is equal to 0 because of that restriction that we've got. And that's about it.